In this course, we are going to explore some PINs-related technologies that can be considered as advanced topics. These technologies are, well, in its core, are PINs-related technologies. However, it does have new ideas. We will start by exploring the topic of inverse pins. Inverse pins is a technology that uses pins network along with some data related with or acquired from a solution of that specific problem. These data, along with the already pins model, can be used to discover a specific value. For example, if we have a flow field, we can discover its viscosity or the thermal diffusivity of that specific fluid and that specific example or the data generated from the data generator of that specific example. After that, we will explore the deep neural operator, and we will use for that the DeepONet, which can be considered as a very important network because it does summarize how can a neural network solve equations or do complex operations such as in differentiation or integration, and along with solving or predicting the future result or how the fluid will behave in the future. After that, we will also continue with the deep neural operator, but this time we'll use a bit more advanced method, that is the Fourier neural operator. We will understand how this Fourier neural operator works, and we will build a model that can predict the Darcy flow problem, or can solve Darcy flow problem in this course as well. After that, we will go to the 3D LLM, and we will solve a linear elastic problem for a 3D geometry. What we can consider it as a bit more complex geometry. Once we have done that, we can also solve a 3D problem. However, this problem has the added value or the complexity of it has multi-domain problem. That is, we have to solve the fluid and the fluid flow as well as the solid part of the problem. This is a heat exchanger problem, so the heat will propagate through the solid, and after that it will propagate through the fluid itself. We will have different governing equations and different neural networks to solve this problem. So it is quite interesting problem. The last problem we will solve is a geometric optimization using pins, in which we will have an input of this neural network that are parameters that will govern how the geometry itself has to be be constructed. So we can consider, for example, different types of materials or different geometries of heat exchangers as an input to the neural network. Let's work together and get more familiar with NVIDIA Modulus. I hope after this course we will be able to model complex problems that are related with pins, inverse pins, deep neural operator, and more using NVIDIA Modulus, and be able to successfully solve these problems and provide a good product for our company, or a nice and innovative research content for our master's, PhD, or bachelor academic course.